Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaru. Students, in this physics, recently we have started heat. In that, some of the topics we have completed. Basics of heat, temperature and different temperature scales we have completed. Okay. Now we are going to discuss the topics thermal expansion of heat and Newton's law of cooling. Okay, so these two are very important. First of all, thermal expansion. What is this thermal expansion? Thermal means heat, expansion, that is dimensions increase. Okay, so that means if you give the thermal input or if you increase the temperature, the dimensions of any objects will be increases. Dimensions in the sense length, breadth, thickness, all those. Okay, so here you can note down the point. If temperature changes, if temperature changes, what will happen? Dimensions of any object or body, dimensions of body changes. Okay, so that means in simply, if we increase the temperature, dimensions are increases. Dimensions of body increases. Okay, so the body is any form, that is solid form, liquid form, gaseous form, whatever it may be. If we increase the temperature of the object, then those dimensions will be increases. Dimensions in the sense maybe length, breadth, thickness, it is. Okay, so length breadth means you can say area will be increases. Length breadth height means you can say volume increases. So that means all the physical dimensions of the body are going to be increases. Let us take a solids example. Let us take solids. In case of solids, as temperature increases, as temperature increases, all dimensions are increases. Dimensions of body or dimensions of object. Dimensions of object increases. Okay, dimensions of the object increases. You can also observe this one. In case of summer, the metals are expand. In case of winter, the metals are contracts. Metals are contracts. Okay, so we can observe it. We can observe it. In summer, metals are expand in all dimensions, length, breadth, thickness, all will be expands. In winter, metals are contracts. Okay, that means we can observe in electrical wires outside, that is besides of the road we have electrical wires now. Aluminum wires, aluminum is a metal. If you observe in the summer, they will be expand. So because of the expand, the span is like this. Okay, in case of winter, what will happen? The same wire is contract means they have like this. Okay, so very here contract, here expands. Like this you can observe in our real time. Okay, now here whenever the temperature increases, the all the dimensions are increases means length increases, breadth increases, Okay, thickness increases. So that means you can say based upon this we have the three factors are there. Okay, first one lead length means one dimension, that is linear. Length, breadth, area, that is superficial. Length, breadth, thickness, that is you can say volume. Okay, so based on we have three types of expansions are there in the solids. Okay, those are linear expansion. Second one aerial expansion or superficial expansion. Third one is nothing but volume expansion. Okay, so we can take those three here. Three types of expansions in solids. Three types of expansions in solid. Those are first one linear expansion denoted with the letter alpha, and second one superficial expansion, that is beta. Third one volumetric or volume expansion, that is gamma. Okay, so let us take each and every one. First one linear expansion. Linear means only one dimension. It is a one dimensional expansion. One dimensional expansion. So either length or breadth or thickness. So length is one dimension, breadth is another dimension, thickness is other dimension. So here linear in the sense length. So you can say as temperature increases, length of material, length of object or material is increases. Okay, this type of expansion is nothing but linear expansion. Here coming to coefficient of linear expansion, coefficient of linear expansion, that is nothing but change in length by actual length into change in temperature, change in temperature. Okay, so length same units means per degree centigrade is the units. Okay, second one superficial or aerial, superficial or area expansion, that is beta. Okay, so here it is a two-dimensional expansion. Here as temperature increases, two-dimensional, that is area of the object increases, area of the object increases. Okay, so area in the sense length into breadth, so both length and breadth are increases. Here coefficient of superficial expansion beta is equal to change in area by actual area into change in temperature, change in temperature. Here also units are per degree centigrade. Third one volumetric or volume expansion, volume expansion, that is gamma. Okay, it is a three-dimensional expansion. Okay, so here as temperature increases, volume of the object increases, volume of the object increases. So gamma is equal to delta V by actual volume into change in temperature. Okay, and we have the relation between these three, alpha is to beta is to gamma. So alpha only length increases, beta length into breadth, that is area increases. Here length into breadth into height will be increases. So here if you can consider the relation, here 1 is to 2 is to 3. Okay, so it is the first one dimensional, two dimensional, three dimensional. So the ratio is nothing but 1 is to 2 is to 3. So the relation, this relation very important for exams. Okay, you may not get any other. This is the chance to get the question. Relationship between alpha is to beta is to gamma in the heat. That is 1 is to 2 is to 3. 1 is to 2 is to 3. Okay. So if you can consider the same expansion in liquids and gases. In liquids and gases also almost the same. In liquids also, if you increase the temperature, the volume of the liquid is going to be increases. Okay. So thermal expansion in liquids. Expansion in liquids. Okay, so note down the point. If you we can if you want to increase the temperature of the liquid, we may not heat the liquid directly. So what we have to do, we have to take the liquid into any one vessel. We have to take any one vessel, that is a solid, and we have to fill the water or liquid into that one. Okay, so if you heat the vessel, then what will happen? The heat will be transferred from vessel to water, and in the water from one molecule to another molecule. The heat will be goes to from one molecule to another molecule. So like that the temperature, that means the liquids are heated up, correct? So note on that point. If you take or if we take any one vessel and pour water in it, one vessel and pour water in it, and then if we heat the vessel, the heat transferred from vessel to water, I mean liquid, water to liquid. Okay, water to liquid, and then volume of liquid increases. Okay, so finally what you can say, as temperature increases, volume of liquid increases. Okay, so whenever we start the heating, first of all vessel is heated up. Whenever the vessel heated up, it expands a little bit, and after that the heat will be transferred to the water, and in the water, molecule to molecule, water is going to be transferred, and that is heated up. So the volume of liquid is somewhat of increases. Okay, the gas is also same. In case of gas is also same. As we increase the temperature, volume of gases increases. That means gases also expands. Okay, here one important topic is there, that is the liquid. If you can consider water will behave, that is water behaves differently We can call that one as anomalous behavior of water. Anomalous behavior of water. Why? Because if you can consider the water at 0 degree centigrade, how the water will be in the ice format, correct? And whenever we heat that one from 0 to it reaches to 4 degrees centigrade, then it will become so again water. And if you can consider from 4 degrees centigrade to up to 100 degrees, let us take it is a 10 degrees or 20 degrees or 30 degrees, whatever it may be, it is again in the water only. So then what will happen? Whenever if it has the ice format, it occupies more volume, correct? If you take one glass, in that if you take some ice cubes, it consumes more volume, so the volume is more. Okay, the volume is more when it is in the form of ice. Whenever it converts ice to water, then what will happen? Whenever it becomes water, then it occupies less space. So then what will be the volume? Volume is going to be decreases. We can observe this one. Okay, take some water in the glass. Okay, so in the glass, that is, take white color glass, it will be visible very clearly now, and mark that one at where there is a water. Okay, we have to mark that one at that place and kept that one in the refrigerator. Okay, after 5 hours or 6 hours it will becomes ice. Then observe the value. So it has somewhat of more, so that means what you can say, whenever the water is in the ice format, it has more value. Okay, more volume, and whenever it converts into the water, the volume is going to be reduces. And we know very well, whenever in the liquids, as temperature increases, volume is going to be increases. So from 4 degrees centigrade to 10 or 20 or 30 or 100, whatever it may be, as you increase the temperature, volume of the water is somewhat of increases. So then volume is going to be increases. So first of all, what is happening? High value to low value. First of all, volume decreases. Volume decreases from 0 to 4 degrees centigrade. From 4 degrees centigrade to, let us take it is example 10 degrees centigrade or 20 or whatever it may be, volume low to high. Low to high means volume increases. Volume increases. Okay, all of you clear? So initially from 0 to 4 degrees centigrade, volume is going to be decreases. And from 4 to 10 degrees or 20 degrees or 30 degrees or whatever it may be, so then water volume is going to be increases. So it is the different behavior of the water. Okay, so that's why water has anomalous behavior. Okay, so we know very well what is the density. Density is equal to mass by volume, correct? So as volume is less, density is more, correct? So at which volume is very less? Volume is very less at 4 degrees centigrade. So we can say maximum density at 4 degrees centigrade. Maximum density at 4 degrees centigrade. All of you clear? So at 4 degrees centigrade, the volume is very less. So density is more. So very important question. Maximum density of water at which temperature? 4 degrees centigrade. All of you clear? Okay, so note down that point. Anomalous behavior of water. Anomalous behavior of water. This is a real time thing, that's why it takes somewhat of time to understand. Okay, so water shows anomalous behavior on heating. Okay, water shows anomalous behavior on heating. Okay, temperature from 0 degrees centigrade to 4 degrees centigrade. What is happening? 0 means it is in the ice format. Volume is high. 4 degrees centigrade means water format. Whenever it is in the water format, the volume is less. So 0 to 4 degrees centigrade, what is happening? Volume high to volume low. So high volume to low volume means volume of water is decreases. Volume of water decreases. Clear? Okay. And from temperature more than 4 degrees centigrade to higher, then what is happening? 4 degrees centigrade means volume is less. Higher, if you increase the temperature, volume is increases. So lower to higher means increases. So volume of water increases. So finally what you can say? So volume of the water first decreases and then increases. So volume of water first decreases up to 4 degrees centigrade and then increases from 4 degrees centigrade to higher. Okay, 4 degrees centigrade to higher. Okay, and here at 4 degrees Celsius, water volume is very low. So density of water is maximum at 4 degrees Celsius. Very, very important. Density of water is maximum at which degree centigrade? That is 4 degree centigrade. All of you clear? All of you clear? Very important one. Now after this, we have discussed different types of transmissions of heat: conduction, convection, radiation. Okay. Transmission of heat. Okay. Here we have three types of the transmissions. One is conduction, second one convection, third one radiation. Okay. First method is conduction method. What is this conduction method? That is nothing but direct heating. So if you take any one solid, any one vessel, okay, any one vessel, any one solid, we can directly heat that one. Correct, direct heating. Direct heating. This process is nothing but we can say conduction process. Okay, so in case of liquids, can we heat the liquid directly? That is not at all possible. So we have to take that liquid into any one solid or any one vessel. To take vessel, and if you can consider it is a liquid, So we have to take the liquid into the vessel and we have to heat that vessel. Then heat is transferred from vessel to liquid and liquid to liquid, that is molecule to molecule. So this type of heat transfer is nothing but you can say convection process. Convection process. Radiation process. For example, we are getting the heat from the sun. Okay, we are getting the heat from the sun. Due to that heat, water is heated, solids are heated. Okay, so that means here without any contact, no contact, no contact. Also, those are heating. This process is nothing but you can say radiation process. Radiation process without a contact. So direct heating or direct contact is conduction. Indirect contact is convection. Indirect contact is convection. There is no contact is the radiation. Okay, all of you clear? Conduction is direct heating. Direct heating, that is nothing but direct contact. Contact heating. Generally solids. We can heat the solids directly. Okay. Can heat the solids directly. So example, solids. So in the solids, there is a direct contact of heating. So that is conduction process. So it is the slowest process. It is slowest process. Among all the methods, conduction process is very, very slow. Second one, convection. Convection, indirect heating or indirect contact heating. Heating, that is indirect contact. Okay. Here we have to take any one medium, that is any one vessel, and we have to take that liquid into the vessel and we have to heat that one. Okay. So here note down by this method we take liquid into vessel and we heat vessel. We heat the vessel by conduction process, then heat transferred from vessel to water by convection process, that is without indirect contact. Okay, so then heat transferred from vessel to water by convection process, and in water heat transfer from one molecule to another molecule to another molecule. Very important question here. The molecule to molecule transfer takes place in which process? That is convection process. That is convection process. Okay. So in water, heat transfer from one molecule to another molecule. So in convection, molecule to molecule, molecule to molecule, heat transfer takes place molecule to molecule. Takes place molecule to molecule. Very important point. Okay, molecule to molecule. Now coming to the third one, radiation method without any contact. Radiation process without any contact. Without any contact. Okay, without any contact. So here heat transfer takes place without any contact. That is, we observe the heat from the sun. We observe the heat from sun is without any contact. Okay, without any contact. So here, this is example generally takes place in gases. This is convection method is takes place generally in liquids. Okay, so here, what is the fastest method? The fastest method is nothing but radiation process. Okay, so through the radiation, we can say if we want heat the object through the radiation, that is without any contact, means we can heat at every direction. We can heat at every direction. So the heat transfer takes place fastest. Slowest heat transfer, conduction. Conduction. Slowest heat transfer takes place. Okay. So these are the methods of heat transfer. Okay. Now coming to the next one, Newton's law of cooling. A very simple law. Newton's law of cooling. Okay. Heat transfer takes place whenever there is a difference in the temperatures. Okay. So according, note down, according to this law, so when that is heat transfer rate, transfer rate depends upon the difference between the two objects. Okay, whenever we have one object, here another object, here it is 100 degrees centigrade, it is 10 degrees centigrade. If you place this one upon this one, or if you place these two are in the contact, there is a difference of 90 degrees. So heat transfer takes place as very much as fast because there is a lot of difference. So that's why heat transfer rate is fast. And if you can consider one object is just 30 degrees, another object is 20 degrees, then the difference is 10 degrees only. So that's why here heat transfer takes place slow, very slow rate. Okay, here it will be transfer fast rate, here it will be transfer very slow rate. Okay, so according to this law, the rate of cooling or heating, whatever it may be, cooling of body is directly proportional to the temperature difference of body and its surroundings and its surroundings. Okay, higher the temperature difference, higher the rate. Okay, higher the rate. So can say rate of heat loss proportional to difference of temperature between them and its surroundings. We can observe this one in the AC rooms. Okay, so how we can observe this one? For example, in summer we can experience this. In summer, let us take in night time, outside temperature is, let us take a 35 degrees, or let us take a 32 degrees. Okay, 32 degrees. Let us take that also in the room temperature, 32 degrees centigrade. If you put the AC in 28 degrees centigrade also, okay, 28 degrees centigrade also, there is a 4 degrees is the difference. Then we feel somewhat of cool air. Okay, the persons who are in the room are feeling somewhat of cool air. If you can consider the same in winter, okay, outside temperature, let us take a 27 degrees in our winter, or not only winter, not summer, if it is not a summer, in general days. In general days. If the room temperature is, let us take 30 degrees, if you place the same in a 28 degrees, you may not feel that much of cooling. Okay, why? Because here just a 2 degrees difference is there, so there is you may not feel that much of difference, that much of difference. Okay, so if you can also observe so many ways. For example, if you place one ice cube is approximately, it is a 0 degree centigrade. If you place that one at any room temperature having 30 degrees centigrade, okay, so then water, that means ice will becomes water in a faster rate. In a faster rate. Okay, so it loses the temperature very faster way. And in the same way, if you take some water in 20 degrees centigrade, if you place the 20 degrees centigrade of water in the 30 degrees centigrade of room temperature, then it takes a lot of time. It takes a lot of time to convert 20 to 30. Correct or not? For example, from 0 to 20 degrees centigrade, it takes maybe 10 minutes. 10 minutes to lose its temperature 0 to 20 degrees. Okay. And in the same way, from 20 to 30, it takes nearly 30 minutes. Why? Because here temperature difference is 10 only. So that's why it takes a lot of time to become 20 to 30. Here 0 to 20 means there is a 20 degrees difference is there. So that's why the ice is more fastly become into the 20 degrees of the water. So whenever there is a temperature differences are more, then heat transfer takes place more. Okay. If we have two objects, object A is 30 degrees, object B is 30 degrees, then what will happen? There is no temperature difference. No difference. No difference means no heat transfer or cool transfer takes place. No heat transfer takes place. Okay. Whenever there is a temperature differences are same, that is temperatures of the objects are same, then there is no heat transfer takes place. Okay. So here, higher the difference, higher the rate of transfer takes place. Okay. Okay, students, we will discuss the remaining in the next session. In the next session, I will give MCQs on this topic. Okay. All of you, thank you so much for watching. Take care. Bye, guys.